Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here we go with another awesome video on learning chemistry. Again, the Crazy Hat Chemist is your source for all things that go real chemistry and learning actual real chemistry. So that's why you're here, and that's what we're going to do. So here we go. We're going to plow on through this worksheet. It shouldn't be too bad. It's pretty easy. I am hoping that you have previously watched my atomic structure GC, that's general chemistry worksheet number 1 and number 2, prior to attempting to do this. That would be most helpful. You also need, most certainly, a periodic table. I am using a specific periodic table, but any periodic table will do under these circumstances for today's activity. All right, so first thing here is just a little bit of a review right over here. This is standard nuclear notation. So standard nuclear notation is where A is the mass, and the mass is actually the sum of the protons, and I'll emphasize that with this plus sign here in red, and the neutrons. Then Z is the atomic number. That is actually equal to only just the proton. So if I were to take the difference between these, I will get the number of neutrons. All right, fantastic. So that's one of the things that you have to know with standard nuclear notation. One other thing here is that if there is a 0 right there, or if there is no number, then there is a 0 implied and assumed. And if that is the case, that 0, if this equals a number that is not 0, i.e. either a positive or a negative, then this is not an atom, but an ion. An ion, okay? And so we're going to have lots of examples of ions here today. When the charge is neutral or 0, that is this number right there, then there is an equal number of protons and electrons. When the charge is either positive, when the charge is positive, then there are more protons than electrons. So when this charge right here is positive, there are more protons than electrons. When the charge is negative, there are more electrons than protons. Okay, fantastic. That should help you with performing everything that you need to on this worksheet. So at the title here of each column, we're going to have the element and we're going to have the symbolic notation. Notice that symbolic notation is in standard nuclear form. And then we have the atomic mass, we have the atomic number, we have the number of protons, the number of neutrons, the number of electrons, whether it's an atom or an ion, and then the net charge of that atom or ion. So that's what we're going to fill out for the rest of this. Keeping in mind what we have learned right up here, again, you need to make sure that you have watched the atomic structure general chemistry worksheet 1 and 2 videos before attempting to do this one. All right, so I'm going to slide this on up so that will give you more of this worksheet. And I'm also going to zoom in on just the table portion so that we just see that here. Okay, that's going to be critical here for us. All right, fantastic. So this is what we're looking at right here. So this is perfect. So what we're going to have to do is work with the information of which we have here and the periodic table. The periodic table is going to be our friend. It's never your foe, your friend. So here we go. We have, what do we have given? It says phosphorus 30 ion. So, well, is it an atom or an ion? Well, it's an ion because it says that it's an ion. So hopefully that's explanatory. This 30 over here, just like on the previous worksheets, that means the mass. So the atomic mass is 30. That means the A in the standard nuclear notation is actually a 30. All right, so now what we're going to have to do is we're going to have to find the element phosphorus on our periodic table. And so this shouldn't be a hunting game because we have 118 elements in which to potentially choose from. Well, we want to narrow it down quite a bit. And this number 30 here is the mass of this particular isotope. Now, it will not necessarily match that which is on the periodic table. but it will be close. So these are average masses that I'm circling here that are on the periodic table. You will not find necessarily that number 30 exactly on the periodic table, right? This 30, because that is the mass, that is the A, that's the mass, and these numbers are the average masses of all the naturally occurring isotopes. This is only an isotope. Okay, so you will find it roughly within this region, and here we go. There is phosphorus. The symbol is just a capital P, and then the atomic number is 15. So we're going to make use of both of this bits of information here. That's the 15 for the atomic number and the P for the symbolic notation. So it's a P, and the atomic number is 15. The atomic number is 15. Okay, so now what we're going to do is we're going to get the number of protons. Well, the atomic number and the number of protons are always equal to each other. You should have learned that on the previous two worksheets. So that means that there are 15 protons if the atomic number is 15, since they are equivalent to each other. Now, what we need to do is we are going to subtract these two numbers right here. We're going to take away 15 from 30, and that will be 15 in this particular case. That is the number of neutrons. So if you recall, back up over here in standard nuclear notation, the A is the mass, which is the protons and the sum of the neutrons. So that 30 in this particular case is the neutrons and protons. This Z is the atomic number that is equal to the number of protons. And so that's the number of protons right here, this 15. If I were to subtract these, then I'm going to get the number of neutrons. Fantastic. Hopefully that makes sense to you. So then the next part here is we need to get the charge on the ion. So what we're looking at to get the charge on the ion is we're taking a look at the difference between these two numbers here. And which one is greater? Well, I either have 15 or I have 18. 18 is greater. Electrons are negative, so that means that this has a negative charge. Then the one that is greater, by how much is the difference? So if I'm going to take the difference between these here, I'm going to get a difference of 3. That is 18 minus 15 or 15 minus 18. It doesn't matter the order, but the difference is a 3. Now, that's what we get. We get a 3 minus. So the net charge on this ion is a 3 minus. So I'm going to place that 3 minus right here, a superscript right there. It is by convention that the number comes first, the charge comes second. Now we have standard nuclear notation of an isotope of an ion of that isotope. Fantastic. That's our first example. And let's keep on going and see if we can complete the rest of this. We have a number of squares in which to fill in, and we'll be able to do that here. So this next one here, we have the standard nuclear notation. It has this 2+ charge right there. So I'm going to place that in the net charge that's 2+. Since it has a charge to it other than 0, that means that this is an ion. Perfect. This 29 is the atomic number, 29. Remember, the 29 of the atomic number and the number of protons, they are equal to each other. Okay? And this 63 is the sum of the protons and neutrons, which is the atomic mass. So that's 63. Perfect. If I take the difference between 63 and 29, I'm going to take the difference here between the 63 and the 29, and I am going to get the number 34. 34 is the number of neutrons. All right. Now, which one is greater? Now, since this is positive, that means that there are more protons. Since this is positive by 2, that means there are 2 more protons than there are electrons. So I'm going to take away 2 from this number of 29. That will be 27 electrons there. Perfect. So if I take the difference between these, I get the number 2. That's why that's a 2. There are more protons, which are positive. That's why that's positive. Now I need to look on my periodic table, and I'm going to find element number 29. Now this is much faster than the phosphorus that we had before, because we are actually directly looking at just number 29. That is a Cu. That does correspond to that symbolic notation that was given there. And the name of this element is copper. All right, so we're going to write that down, copper dash and the mass, which is 63, and then it's an ion. Perfect. All right, that looks good. We got our second one done now. All right, now let's continue on. So this next one here is atomic number 29. Now, normally, if we didn't already do the previous problem, what I would do is I would look up here and find atomic number 29, and it is Cu, and it is copper. So that is still correct. So this is copper dash, and the atomic mass is now 65. So this is a different isotope. Okay, it's atomic number 29, therefore there are 29 protons. It says right here that there's a +1 charge, so that means that this is an ion. That's correct. Okay, and we already know that it's a Cu. There's a 1+ charge here, so there's going to be a superscript of a 1+ charge. The mass is 65, and the atomic number is 29, and this is an ion. Now we need to figure out the number of neutrons, and that's the difference between the atomic mass and the atomic number. So it's 65 minus the 29, and we're going to get the number 36. 36 is the number of neutrons. Now what we have to do is get the number of electrons. So now that this is positive, since there's a net charge that's positive, that means that there are more protons. How many more protons? One more proton. So I'm going to have 28 electrons. Perfect. Hopefully you got that one nailed. All right, let's do our next one here. Our next one has a number of protons at 8. That means the atomic number is 8. To get the mass, I'm actually going to sum up the protons and neutrons. So that's 8 plus 9, that's 17. That's 17. All right, perfect. Now it says that it's a 2- charge. That means that this is an ion. All right, fantastic. Since it's a minus charge, that means that there are more electrons than there are protons. So there are 2 more electrons than protons. There are 8 protons and there are 2 more. So I'm going to add 2 to 8 and I get 10. I'm going to look on my periodic table and I'm going to find atomic number 8. Okay, atomic number 8 is right here. That has a symbol of an O, and that is the element oxygen. So it has a symbol of an O. It's the element oxygen, Oxygen. It's a dash 17, and it is most certainly an ion because it has a charge. The mass is 17. The atomic number is 8. It has a charge of -2. Now I've completed that one. That's looking pretty good now too, I think. All right, let's tackle the next problem here. So we have protons at 55 and neutrons at 78. So if I were to sum up the protons and the neutrons, that will give me the mass, and that mass is 133. Beautiful. This has a plus charge. Whether it has a plus charge or a minus charge doesn't matter, but it is an ion. At least we know that. We can write the word ion here at the end. Then the number of protons is equal to the atomic number. So 55 protons, that means the atomic number is 55. Since it has a positive charge, there is more protons than electrons. Since it's a 1 positive charge, that means that there is 1 more proton than there are electrons. Since there are 55 protons, that means there must be 54 electrons. I'm going to look on my periodic table and I'm going to find element number 55. And so I'm going to find element number 55. There's 55. That's a capital C lowercase s, and that is for cesium. So that is CS, cesium, CESIUM -133. And like we said, that was an ion. Its mass is 133. Its atomic number is 55, and its charge is a 1+. All right, fantastic. You guys are doing fantastic. Hang on. We are about almost halfway done with this worksheet since we had a little bit there at the top. All right, this next one has a 3+ charge. That means it's an ion. All right. It has 21 protons. That means the atomic number is 21. If we were to sum up the protons and the neutrons, that will give us our mass. That will be 46. So 46. It has a +3 charge. So that means that there are more protons than there are electrons. Since there are 21 protons, that means we're going to subtract 3 from this, and that will give us 18 electrons. I'm going to find atomic number 21 on our periodic table, and that is right here at 21, and that's Sc, and that's for scandium. All right, so Sc, it's a 3+ charge, it's a mass of 46, it's atomic number 21, SCandium-46, and it's an ion. Okay, you guys are looking fantastic. We are still not quite done. So what we're going to do is we're going to slide this paper up, and I'm hoping that you're going to remember the headings that belong up here on this. So don't let go of those. Okay, but we do need to slide this up because we have more of this worksheet here at the bottom. So I'm assuming that you've got those headings. They're perfectly fine. We've been using this consistently. A little bit of self-advertisement, selfless self-advertisement, and that is I am the crazy hat chemist. I am where you want to go if you want to actually learn chemistry. This is in general chemistry, but I do have honors chemistry for high school, which is like a college prep chemistry, and I also have AP chemistry videos. And please watch all those videos depending on what level of chemistry you are looking for. And this is the place, the Crazy Hat Chemist. This is the place where you get all your chemistry needs met. Absolutely, most certainly. Okay, without further ado, let's carry on here and see if we can finish up this worksheet. So this next one is an ion. It's an ion, and you can clearly see this with this +6 charge as well. The mass is 238, so 238 for the mass. That will be this top number, 238. And this is uranium. So I'm going to look on my periodic table for masses that are close to 238. It doesn't need to equal exactly 238, but there we are, uranium, and that is a capital U and an element number 92. Okay, so that is a capital U, it's atomic number 92. Atomic number 92, number of protons, 92. Okay, and it has a 6+ charge, so we're going to write this 6+ charge right there. We're going to take the difference between that 238 and that 92, that is the atomic mass, minus the atomic number. I'm going to get 146 for the number of neutrons. I'm going to take the 92 and I'm going to subtract 6. So that means that I will have 86 electrons. Remember, if it's positive, that means that there are more protons. By how many more? 6 more protons. So you can always just double check your work and add 6 to this right here, and you should get that 92. So 86 plus the 6, that's equal to 92. That's correct. All right, let's move on to the next problem. The next problem, actually the next two, are isotopes of each other. They are different ions and different isotopes. Okay, this one has a 2+ charge, so it most certainly is an ion. Absolutely. Okay, and the atomic mass is 58, so that goes right here in the atomic mass column. The atomic number is 26, that goes right here. The number of protons is equal to the atomic number, which is 26. If I take the difference between the 58 and the 26, I'm going to get the number of neutrons, which is 32. Now I need to figure out the number of electrons. So there are 2 more protons than there are 2 more protons than there are electrons. So 2 more of these protons than electrons. So that would be 24 electrons. That would give me that that +2 charge. So I'm going to look on my periodic table and I'm going to find element number 26. Element number 26 is right here. That's 26. That's capital F, lowercase e. That is for iron. So that's matching that Fe. This is for iron. -58, and it is an ion, most certainly. Okay, fantastic. Good job on that one. This next one here, they are two different isotopes because they have two different masses. It is the same element, the same atomic number, but they are different ions of different isotopes, different charges. This has a 3+ charge. Since it has a charge other than 0, it's an ion. And this one we're going to be able to do much faster than the last one because we have most of the previous material here. So we have the atomic mass, that is a 54. The atomic number, 26. The number of protons, 26. Okay, there are 3 more protons than there are electrons. So I will have 23 electrons because it's positively charged. I have the 3 more protons. So now I'm going to take the difference between 54 and 26. That will be 28. That is the number of neutrons. We already looked up number 26 on our periodic table. That is iron, and it is isotope of iron of 54, and it is an ion. Fantastic. All right, this next one here is a net charge of 0. So this is an atom. It is not an ion, as well as you can see this word atom right there denotes that 0 charge. That means there are the same number of protons and electrons. This is like the previous worksheets that we had done prior to this, worksheet 1 and worksheet 2. So what we need to do is look on our periodic table and find a mass around approximately 140. And let's see if we can do that. We will have a mass approximately in the 140 region, and there it is, and that is barium. It did say barium. It is capital B, lowercase a, and that's element number 56. So it's a capital B, lowercase a. It's going to have a net charge of 0. It's a mass of 140, and it is atomic number or element number 56. So that means that the mass is 140, the atomic number is 56, the number of protons is 56. And since this is an atom and it has a net charge of 0, that means that the protons and the electrons are the same in number. Okay, now what we have to do is take 140, subtract 56, and we will get 84. That is the number of neutrons. Beautiful. We have one more to do here, folks. So let's see if we can hammer this out. So the atomic number is 79. That means the number of protons is 79. You should see that the number of protons and the number of electrons are not the same. That means that this is an ion. Which one is there more of? There's more protons. That means that this is a positive ion. And then in adding more to this, there are 3 more positive protons than there are electrons. Okay, so that will give me a 3+ charge. If I were to add up the neutrons, the 119, and the protons, the 79, I will get the following number, and that is 198. That 198 is right here as the atomic mass. Right, fantastic. So that 198 goes right up here as the mass. The 79 goes right there. And then I'm going to have a 3+. So now what I need to do is figure out what element it is by this 79, the atomic number. And then I'm going to put that symbol and then write the name of that element. Here we go. And I am the crazy hat chemist, right? So this is atomic number 79. It's AU, capital A, lowercase u, and that is most certainly gold. And you are watching a golden video right here. That's why it's the crazy hat chemist. You're watching a golden video. It's AU. It is gold. And it is -198. And it is an ion because it has a charge to it. Okay. Fantastic. So I'm going to zoom on out of this video here, or this sheet of paper, so that you can see its entirety. So you can see all the problems within this one worksheet here. And hopefully, let's see if I can do this for you. Here we go. There is almost everything. We're getting closer. There we go. I think we got it this time. So this is the atomic structure general chemistry worksheet number 3. This is the last in the series of these. This is the entire worksheet right here. I'm hoping that you learned a lot. You should give me a thumbs up on that video. Please subscribe to my YouTube channel. And I love you, and we'll talk till next time. This is the place for all your chemistry needs. See you later. Bye for now.